This is so frustrating. This is not how any of it works, and the account itself has not posted a follow-up. As luck would have it, I actually made a mistake in that video. So let me practice what I preach in two different ways. And one, post a correction to the mistake that I made. And second, in a recent video, I actually gave the advice of making lots of mistakes. So I'm posting this video to show you that I do a lot of math and I make mistakes. So let me tell you what the mistake was and what we've learned in the process. So remember, we were trying to find numbers where you could use this trick to compute the square root. So we're looking for numbers a and b such that 10a plus b is equal to a plus b minus 2 squared. Then I correctly expanded the square, but I incorrectly completed the square. The correct way to simplify that equation by completing squares is, first of all, complete the square in a, but we have a squared plus 2ab, which is what I forgot to take into account. So I have to complete a squared plus 2ab minus 14a. And when I try to complete that, what I get is this equation instead. A plus b minus 7 squared is equal to 9 times 5 minus b. Now, this is an equation of integers, and since the left-hand side is a square, the right-hand side has to be a square. So 5 minus b has to be some squared, let's say n squared. Then a plus b minus 7 will be plus or minus 3n, and I can solve for a since I also know b to be 5 minus n squared. So that gives me that b is 5 minus n squared, and a is n squared plus or minus 3n plus 2. Now, in the problem we were trying to solve, a and b are digits, so they're between 0 and 9. And, well, that gives me that b has to be positive, so n can be at most 2. So it's 0, 1, or 2. And that gives me the pairs a and b, the possible pairs a and b correspond to the number 0, 1, the number 0, 4, the number 25, and the number 64, which were the only solutions that I said there were. However, if a and b can be anything, positive or negative, then there are more solutions. For example, if a is 12 and b is 1, it works. Or if a is 20 and b is minus 4, it also works. So by realizing my mistake, I have found an infinite family of solutions to this problem. They are no longer, a and b are no longer digits of a number, but they are numbers that make this work in an infinite family.